Okay, right, welcome back to the 6th video in this series about working with the APoLUS model. So in the last video, the 5th video, we showed how to calibrate the neighborhood rules. So now I'm going to move into the next blocks and calibrate accessibility. Okay, so we're going to suppose that we've exited the workspace and we're going to start a new day of work, or new period of work, and we're going to start again from scratch. I'm going to show you how to get back into the settings that you left last time when we're doing the neighborhood block. So we're going to find where we have it stored. In this case, I've got it in downloads. There we are, APoLUS 9.6, and hopefully you remember from last time that these key stages in the process of setting up and calibrating the model for our case study area in Navarra in Spain, we were saving our data files with all the settings, and then we were able to bring back in our data files with all the settings that we've made up to that point in the model, and we were able to bring back the maps using, I'm just going to open this with a notepad for now, bring the maps back in using this command. Okay, so that brings the model layers back in as well. Okay, so we're going to do that now. So the last our data file, the last settings file we saved contained the neighborhood rules as well as all this other stuff. So these are progressive, contained our project setup, our actor settings, and our neighborhood rules. So we want that last one. Obviously, if you've made a mess of the neighborhood rules, you might want to rewind back to the actors. If you made a mess of the actors as well, you can rewind back to the very beginning, back to project. So we're storing it at those sort of successive key milestone stages. Okay, so now we're going to open up the neighborhood. Okay, yes, we want to load it into the global environment. And there that is. And then now we're just going to look at, let's just have a look. So we're going to just check that we've got the neighborhood rules. Okay, we're going to search for a pattern. Mat is our pattern. Okay, so those are all our empty neighborhood rules, and not all of them are empty, obviously. I think if we remember, we set up one land use, each land use to itself for the active land uses, which, as I said, is the minimum we need to get this working. Here we go. Yes, that's mat herb is fine. We'll also have set up mat wind. There it is. And also mat solar, which is here somewhere. There it is. Okay. Fantastic, there we are. So those are all our rest. The rest here are all blank. We can set them if we want, going back into the neighborhood block. But remember, for that, first of all, we have to bring up our switchboard. Okay, so this is switch, it's in the switch folder, and it's called switch B. Now that's the switchboard that brings us back to the series of steps that we had. And it also brings in our packages that we need, so it's quite handy. There we go, back to the switchboard. So if we wanted, we could calibrate the neighborhood. This one further thing that we have to do, which is a new thing we have to do in the Terra package. So Terra works directly on these files on the disk, so we don't need to load them into the memory, which is a great advantage, but that does mean that we have to store them and load them back in when we want to work on them, or when we want to display them. So we're going to do that, and as I said before, that's stored here in switch B. We can actually uncomment that if we like, so that comes in every time we load the switchboard, but we don't need to. We can just copy that, and that runs a script, script model blocks, and that will bring in all the maps that we've got so far. And as I mentioned in an earlier video, all the maps that we create as we go along through this phase are stored in outputs model blocks. Okay, so those are all the maps we've worked on so far. We've got some others here. We've got suitability and zoning. These are earlier versions. There's accessibility, suitability and zoning. Okay, so we haven't actually done these yet together. So I'll show you how we create those just now. And as I say, if you're calibrating repeatedly and modifying them, you may want to save your earlier versions. You want to preserve them, so you want to just copy them and put them here. So I've got settings original copy. I've pasted them there. So as you've got particular calibration stages that you want to preserve, I suggest that you you take that out. Yeah, anything that's overwritten there in model blocks, you copy that and put it somewhere else to preserve it, because as you make your new settings, it'll be overwritten. Okay, so let's get started with accessibility. Okay, so accessibility is a simple concept. The purpose of this video is not to explain everything about accessibility in geography and how we deal with that. There's plenty of publications, a lot of literature on those concepts, but just to show you in a straightforward way how to work with this idea of accessibility in the model. So by accessibility, we mean how easy it is to get from one place to another, and in particular how easy it is for one land use to to be assigned or to grow or develop based on how near or how far it is to infrastructures. So for example, roads, railways. Here we're working also with renewable energies, so the electricity network is very, very key infrastructure that we're going to include in our accessibility calibration. Okay, so there's a little bit more theoretical background for this if you're interested in the both the system documentation and also the user guide. So I'll just open up the user guide because I think that's helpful. We can open up the user guide, and here we've got calibrate accessibility. Okay, so this explains a little bit more about what's going on here. Okay, gives us some examples. In particular, it explains us this White's local accessibility equation, which creates a distance decay effect. So a distance curve, the further away you are from, say, a road, the lower this accessibility value that we're computing is going to be. Well, that depends on the coefficient. Okay, the coefficient delta here, delta J, that's the coefficient. And effectively, because this is the denominator, we're actually dividing there by this number we put in. So the larger the number, the flatter our curve is going to be, and the more diffuse the accessibility effect is going to be. Okay, so there's an example of that. It's effectively about the cutoff, or the halving distance we could call it. So if we use a value of 1, we're creating an accessibility, a very, very, very sharp cutoff. So only areas literally on top of roads are going to have high accessibility values. And obviously the larger our coefficient value, the more dispersed that is. And you can see this happening. Okay, so it's gradually becoming more and more and more dispersed. So going from a very, very, very high values, very close to the infrastructures, to much lower values dispersed across the whole area. Right. So this is something you need to think about a little bit. What particular infrastructure types have you got, and how they're going to affect the accessibility of the land uses in your model. Okay, so let's minimize that. Let's set up accessibility. Okay, so the way this works is when we hit the calibrate accessibility button, it's going to access all our Euclidean distance maps, which we've previously stored here. Okay, so these simply are, if you're familiar with ArcGIS, you can simply so this is Euclidean distance to roads. Very, very simple map. Just Euclidean distance from features. Nothing more complicated than that. You can create that in ArcGIS or QGIS or R or anything. It's a very simple standard operation, but that's what you do need that as a starting point. Your Euclidean distance across as a raster map from each of your features. So not the features themselves, but a raster map of the Euclidean distance from the infrastructure features, from the vector line features. Okay, so they're going to be stored there in APoLUS ASCII accessibility, right? And when you hit this, it's going to load all those in from that directory, right? So obviously if you don't put them there, that's not going to work. I'm going to go to calibrate accessibility, 3 layers imported. It's going to ask me, and what it then does is it then goes successively through our active categories in our land use table. Remember, our active categories are the ones that are actually doing the change. They're driving the change. They're overtaking other land use categories or each other. So for each of these, we've got three active categories. We've got urban, solar and wind. And for each of these, it's going to ask us if we want to set the accessibility. And we're going to go ahead and say, so that's come to the first one, which is urban, herbs. We're going to go yes. It's going to ask for a weight. Okay, so the weight here is literally how important this accessibility is for urban land, okay, relative to the other maps. And notice it's asking us for distance to electricity networks, dist-elec. Now for urban land, in general, we would suppose that roads, highways, railways are more important for the development and growth of urban land than electricity networks. You tend to build your houses where the highways are, and then the electricity networks get extended or not afterwards. Yeah, so we're going to give this just a weight of 1. Okay, we're going to assume that any effect it has is quite dispersed. So we're going to give it on 10,000. Okay, we look at rail. We're going to say railway, perhaps we might think relative to electricity networks for urban land is perhaps a little bit more important than electricity networks. Give this a weight of 10. Going to give it the same dispersed coefficient value, 10,000. But what's really driving the location of our urban areas, we believe, in terms of accessibility, is the distance to roads. Okay, so roads here we're going to give 100. Okay, so these values are arbitrary. This is simply an arbitrary weighting according to what we feel, what we think is likely to be the case. So obviously we can adjust these values and see what kind of effects that they produce. So that's all I'm doing there. And we're going to use the same dispersed coefficient, 10,000. Okay, and there it's plotted our map. So that's our map of accessibility for urban land, okay, relative to all the 3 features together. So we've got roads, electricity networks and railways in there. We've created a single composite accessibility map that represents the accessibility for urban land of every area, every part of our study area. So now we're going to move on to solar. Yes, we do. Okay, so if at this point we hit no, that's fine. That's just going to create us a blank map with a value of 1 everywhere. So no effect at all in any part, no differentiation between any part of the territory, all equal 1. Or we can do as I'm going to do, and we can set accessibility for solar. So there we're going to input the weight. So now this is solar energy. So I think this is the most important thing here for the installations of solar energies. Solar energy is the location of the electricity grid. So I'm going to put 100 in there. On the other hand, we wouldn't expect the distance from the electricity grid to have this very long gradual drop off, because it's really very inconvenient to put up your set up a solar farm a long way away. So if you've got the electricity network, half a kilometre away or kilometre away, it's really not that useful. It's better than nothing, I suppose, but really what you want to be absolutely right on the electric network. So we're going to represent this here with a sharper cutoff. So this is a smaller coefficient value, as I explained before, which will give us a sharper cutoff. I'm going to give a value of 1,000. Okay. Distance rail. Well, we think railways are quite important for transporting these parts for the solar panels. So then we're going to give it a 10. Remember, this is relative to the other accessibility features for this land use. Okay, so for solar, we're saying the most important, is electricity, followed by rail. Okay, and then we're going to say roads. Well, we think roads, are probably, they're important, but they're maybe not as important as those other things. Yeah, so I'm just going to give a value of 1 for the weight, and then we're going to continue to perhaps here, again we're talking about roads, perhaps here this distance effect is likely to be more diffuse, so we're going to give it a 10,000 value here, right? Okay, so that's plotted both of our maps, solar and urban, and then we're going to go and plot wind. So wind we're going to treat more or less the same way. So the most important aspect for the most important accessibility layer for wind is the electric networks. We're going to say that there's going to be quite a sharp cutoff. You want to be as close as possible. Railways also very important. Imagine those turbine blades be transported by rail. Something quite important. We're going to gain quite a sharp cutoff. And then roads, I'm going to say important, but maybe not that important with respect to the location. And we're going to give that quite a dispersed effect there, so 10,000 for the roads. Okay, so that just shows you how we've computed our three different. We've taken three different accessibility layers, and we've created a composite map using those three accessibility layers for each of our active land uses, right? So that's successful and job done. As I say, if the cursor doesn't return here, you can just hit enter. And again, your warning message there, it's just doing a bit of cleaning up, and those layers it's trying to clean up don't actually exist. So there's no problem there. What we can do here, so let's just remember save image as we mentioned before. So we're going to save image. Let's try and keep the naming conventions the same. So we had project underscore nhood, so let's save project underscore access. Project underscore access dot r data. Okay, so that's going to store our accessibility settings. Save dot image, not save hyphen image. Okay, so that should work. Oh, and of course, if we want to see our accessibilities, we could say ACIMP tab. Was it AC tab? Oh no, that's a bit annoying. I think we might actually, when we went out, we might actually have got rid of those. Maybe that just cleans them up automatically. Yeah, not to worry. What I wanted to show is actually how to. Oh, maybe that. No, sorry, they're stored there, but for each land use. Yeah, okay, that's good. I thought we'd lost those. Yeah, okay. So for each land use, we have an accessibility information tab, which shows us those settings we put in, maximum, the minimum, the coefficients we chose, and the map created. So we've got one of these for all of our land uses. Yeah, solar and wind. Yeah. So that's the benefit there of saving the data file, is that you're going to save those tables, and that's the settings that you set up, so they're stored there in that data file. Okay, so that's the end of that tutorial block.